Welcome to today's lesson. As we continue with our learning, we kindly request you to subscribe to our channel and also help us to share the link. We are going to look at a Form 2 question under Similarity and Enlargement. And the question reads, the base area of a cylindrical container is 72 centimeters square. The container is enlarged so that the new container is similar to the old container and has a base area of 128 centimeters square. A. Find in its simplest terms the area scale factor of the enlargement. Roman 2, the linear scale factor. Roman 3, the volume scale factor. And then we have part B and part C of this question. One thing that you need to understand is that if you take the linear scale factor, you square, it will give you the area scale factor. And then, if you take the linear scale factor, you cube, you get what we call the volume scale factor. Meaning, if you take the cube root of the volume scale factor, you get the linear scale factor. You take the square root of the area scale factor, you get the linear scale factor. Part A Roman 1, we are supposed to find the area scale factor of the enlargement. To get the area scale factor, we take the area of the new cylinder or new area, we divide by area of the old cylinder. In this case, we have the area of the new cylinder, which is 128 centimeters square. We divide by the area of the old, which is 72. And if you divide by the common factor, which is 8, 128 divided by 8, you get 16. And then 72 divided by 8, you get 9, and that becomes the area scale factor, since you cannot simplify that any further. Roman 2, we are supposed to find the linear scale factor, and we know to get the linear scale factor, given the area scale factor, you simply take the square root of the area scale factor for us to get the linear scale factor. In this case, if you take the square root of the area scale factor, which is 16 out of 9, this one is going to give us the square root of 16 is 4, and the square root of 9 is 3, and that is the answer to this particular question. This is 4 out of 3. We move down. Roman 3, we are supposed to get the volume scale factor, and we know if you take the linear scale factor, you cube, you'll get the volume scale factor. In this case, the linear scale factor is 4 out of 3, and if you cube this linear scale factor, you are going to get the volume scale factor. If you take 4 cubed, you'll get 64. You divide by 3 cubed, you'll get 27, and that becomes our volume scale factor. Part B of the question, the radius of the new container is 20 centimeters. Determine the radius of the old container. We know the radius is the least unit of measurement, which is represented by the linear scale factor. And from the linear scale factor, which is 4 out of 3, 4 represents the area of the new, while 3 represents the area of the old. And in this case, we are given the radius of the new as 20. In this case, we can say 4 represents the radius of the new, which is 20, and we are supposed to find the radius of the old, which is represented by 3. So if 4 is equal to 20, 3 will be equal to what? If you cross multiply, we are going to have 3 times 20 divided by 4. 4 goes to itself once, it divides 25 times. And if you take 3 times 5, the answer is going to be 15 centimeters. The last question is part C. Given that the capacity of the old container is 810 centimeter cubic, calculate the capacity of the new container in liters. When we talk about capacity, we are referring to volume, and in this case we are going to use the volume scale factor, and we know our volume scale factor is equal to 64 out of 27, and we know the capacity of the old container is 810, and the old container is represented by 27, and in this case we can say 27 is equal to 810 centimeters cubic. What about 64? 64 will be equal to what? If you cross multiply, we are going to have 64 multiplied by 810, everything divided by 27, and this one is going to be equal to, we can use a calculator here. We have 64 multiplied by 810, everything divided by 27, and this gives us 19 or 1920 centimeter cubic. But we are supposed to find the capacity of the new container in liters. So in liters, we know 1 liter is equivalent to 1000 centimeter cubic, and therefore 1920 will be equal to what or how many liters? So you take 1920, you divide by 1000, and this gives us 1.92 liters, and that is the answer to that particular question. Thank you for watching and welcome to our channel.